This is going to be a short video just to kind of wrap up our first three sections and also to introduce evaluating functions based off of a graph or evaluating relations based off of a graph. So the first thing we're going to do is we're going to look at our graph, which is this V-shaped relation, and we have to determine if it's a function. Well, our function is that x has only one output, and a way to test that with a graph is our vertical line test. So no matter where I draw a vertical line at, it only crosses through one time. So that makes this a function. Is it linear? So a linear function is a constant rate of change. Now this graph consists of two straight lines, all right? But one of our lines, if we read it from left to right like a book, is a decreasing value, while the other is increasing. So although they both go up to and over 1, one is going up to and to the right one, making it a positive slope. One is going up to and to the left one, making it a negative slope. Since these are not a constant rate of change, this is non-linear. Continuous versus discrete. So discrete data is individual coordinates that I have to pick up my pencil in order to go from one data point to the next. Continuous, which is what this is an example of, moves all the way across my relation without even picking up my pencil. So this is a continuous function. Our domain is looking at our x values, so I'm going to set up our interval. So this one we haven't covered before, so if we can imagine, since these are arrowheads, we're going to extend all the way to the left, forever and ever and ever, and all the way to the right, forever and ever and ever. The arrowheads just mean it's going to keep going and going and going. Well, domain, we want to see the length of it. How far does it stretch across my x-axis? Well, if it's going to continue to go to the left forever, and it's going to continue to go to the right forever, that means we're going to hit all negative values and all positive values. We're actually going to hit all values. So when I write this as an interval, I'm going to say that we go from negative infinity all the way to positive infinity. The range is our y value, so I want to see how low to how high does my graph go. So the lowest point we can actually mark because it goes all the way down to here. So our lowest point looks like it's at -1, and the arrows indicate that it's going to go up forever. So when I write this as a range, I'm going to go from -1 to positive infinity. All right, so that first section was a review of everything that we have been doing so far with functions. This is our new evaluation of functions. So inside the parentheses is our x value or our input. So they want to know for our function, if I have an x value of 2, so I can think of it like a coordinate, what is my output or my y value? So I'm going to go to where 2 is on the x-axis, and I'm going to go up until I hit my graph. Well, I hit my graph at a value of 3. So when x is 2, my y value or my output is 3. I'm going to do the same thing for f of -4. So I'm going to go to -4 since this is my input or my x value. -1, -2, -3, -4. And I'm going to rise until I hit the relation or my graph, and then I'm going to see where it crosses the y-axis at, and it crosses at 1, 2, 3, 4, 5, 6, 7. So my value when x is -4, my y value is 7. The last two questions ask for the reverse. They want to know what is x, so that's what we're trying to figure out, what the x coordinate is, when our output or our y value is -1. So I'm going to go to the y-axis at -1, and I actually hit right away. So when x is 0, that's when I get an output of -1. When do I get an output of 5? So what is my x value? That's our question. When our y value is 5. So I go to 5 on the y-axis. And I actually hit the x, my relation or my graph twice with x. I hit once to the right and once to the left. So there are 2 x values that have an output of -5. So I'm going to count -1, -2, -3. And +1, +2, +3.